Man, I'm thirsty.
Yo, Alex, where'd you get that water from?
The Springfield water system.
Oh, really?
Yeah.
How's that work?
Let's learn a little about it.
Alrighty.
All right, so this is our presentation on the correlation between water demand and revenue for the Springfield water system. A little overview. There's three components of any water resources system: NRS, SES, and the administration and institutional components. A little more specifically for the NRS system, these can consist of reservoirs, hydropower facilities, watersheds, or distribution pipes, anything that has to do with water infrastructure. Specifically for Springfield, we could think of the Littleville and Ludlow and Cobble Mountain reservoirs and all of their respective watersheds. The socioeconomic system consists of local households, fishermen, hikers, anything that has to do with recreational water use. So for Springfield, you can think of the city itself and then some of the surrounding towns like Wilbraham, Chicopee, or Westfield. And then for the administration and institutional component, broadly you have the USACE, or the U.S. Army Corps of Engineers, the EPA, the U.S. Bureau of Reclamation, things like that. And then for New England, there's ISO New England, which is an electric company in New England, and then NERC and FERC. And so for our project, we're looking at pretty much how these three components interact for Springfield. And then specifically for our design question, we look at water demand and revenue, and and found historical trends and future predictions for those two categories.
Alrighty, so this figure here demonstrates how the Springfield water system works. So our main source of water is the Cobble Mountain Reservoir, but we don't take water directly from the Cobble Mountain Reservoir. We send water from the Cobble to the intake reservoir, which in this case in Springfield system is the Proven Reservoir, and all of the water demand that the Springfield water system has to account for is taken straight from the Proven Reservoir. So the Proven, we take water, send it to the treatment plant, and then it's distributed throughout the system. And that's where we can find any data. So to find the data that we used for this project, we looked at the big board spreadsheets, and we took the daily data from 2018 all the way back to 2010, and we took the average on each year of the daily demand that the Proven Reservoir sent to the city. So we checked for trends in our data. We wanted to find how significant each trend was based on the water revenue and the water demand data that we collected. The Mann-Kendall trend test is a way to check the significance of any trends in any data set and whether it's trending upwards or downwards. We found in our data that the water revenue was trending upwards, which means that each year it was increasing. And we found that the water demand for the Springfield water system was decreasing each year. Both of these trends were significant because the p-values were less than 0.01, which means that the trends aren't really an accident and that there's some value behind them. So the water demand, like I just said, the historical trend is coming downward. So in 2018, the water demand that the Springfield water system had each year was less than it was in 2010. The difference ended up being like, I think 11 million gallons per day, the water demand decreased. So the future projections, what does this mean? This means that since our trend was significant, we can expect the water demand to continue to decrease. However, this is important to think about because there comes a threshold where the Springfield Water and Sewer Commission needs to look and say, well, if the water demand keeps decreasing, then eventually it's going to hit a point where this will hamper the system, such as like if the water demand is so low, the pipes aren't always fully pressurized or have enough pressure in them. So then in the summer months when demand spikes because of the hot weather and the summertime, the pipes might burst and the system would become inefficient. This could negatively affect revenue, but until that, we can expect these trends to continue downwards and upwards.
For water revenue, we got the data from the comprehensive annual financial report from the Springfield Water and Sewer Commission. As Noah said, we found a clear upward trend. It increased $11.1 million over the past 10 years. For future projections, we believe that's going to continue to go up. This is because population is continuing to increase, which provides more opportunity for people they can service, as well as the fact that they're doing capital improvement programs, which will both reduce waste and maximize efficiency, both of which will save them money. In terms of graphing them together, just to show the relationship, we found an inverse relationship between the two. Obviously, as you can see, water demand goes down as revenue increases. And that's our presentation.
Thank you for listening.
Thank you.